Morning, guys. Yesterday we have completed the another module, that is bending stress and shear stresses and beams, and it was quite simple. But if you have any problem, you can contact me back once again, okay, on those topics. So let's move on towards the next module. You can write down module. Wait a second. Okay, let's go for module 4. It's module 4. Module 4. Okay, write down. You can write down today's date. That's 2010 20. Okay, so here module 4 bending moment and bending moment diagram and shear force diagram. Shear force diagram. So this is the unit from where you can easily score full 20 marks out of your 100. Okay, so what is meant by bending moment and shear force, okay. Bending moment is the shear something. I want a moment here. These are the beams, okay. This is beam and on a support. If this is the load, this load into perpendicular distance, that means something bending, okay, like this, okay. So this is called as bending moment. Shear force is the same force applied on the beam. The beams tries to shear off. One will go up, one will come down. It pushes down, okay. That's called as a shear force. So now, before moving on towards the bending moment and shear force diagram, you need to understand some of the types of beams, okay, because those types of beams you'll be asked the questions. Basically it will be cantilever beam and simply supported beam, but still let's see what type of beams are there in our civil engineering. So you have already studied this in your first year. So let's move on towards the cantilever beam. You can pause this video and copy down these things, okay. uh, a beam is said to be a cantilever beam is said to be a cantilever beam when one end is fixed and other end is free, okay. You can see here in the figure, one end is fixed and other end is free. That type of beam is called as cantilever beam. Next comes simply supported beam. A beam is said to be SADI, okay, it is written wrong. A beam is said to be simply supported beam when it is freely resting on the two supports at the end. So two supports at the end, the beam freely rests. So this is called a simply supported beam. Next, fixed beam. A beam is said to be a fixed beam when it is fixed on both the sides. Next, continuous beam. The continuous beams are the beams which has more than one support. You can see here, this is called a simply support, and if there is one more support, then it is called as continuous beam. Then overhanging beam. A beam is like that of simply supported beam only, provided the end is extended beyond the support, okay, extended beyond the support. That extended portion is called as overhanging. You can see here the beam is simply supported only, but the one end is extended over the after the support also, so that is called as simply support, and this part is called as overhanging, okay. So these are the types of beams. One more is there, propped cantilever. It is similar to that of cantilever, which is fixed at one end but is supported on other end. So it is fixed at one end but supported at another end. Then types of loadings. Okay, next coming on towards the types of loading. Point load. So point load. A load is said to be a point load if it acts at a single point as shown in figure W. See here. So this is simply supported beam. A point load is acting at a point. So this type of load is called as a point load, UDL. So this type of load is distributed uniformly over the length of the beam and is called as uniformly distributed load. So W is the intensity, this is expressed in terms of kilonewton in point load. So this is expressed in terms of kilonewton per meter. So this is the UDL, which is spread over the total beam. Now UVL, uniformly varying load. So this type of loading system, in this type of loading system, a load with an intensity of W goes on varying over the length of beam. So see here. So on this beam, so no constant load, it's varying. So from 0 to something height, shown in terms of like this arrow marks down. So this is also expressed in terms of kilonewton per meter. Next we will go, which is very important, very important, sine conventions. So let's see what is meant by those. So you can note down sine conventions means when the load is upward or when the load is downward, what are the things to be known. Consider a simply supported beam with 2-point load on it. So I'll consider as per the consideration with the 2-point loads on it, that is W and W, which is a distance A from equally from the support. So let us consider now cut the beam at the distance x from the support by taking section XX. So now we can say, let's take down shear force first. So let's see what will be the sign of shear force when it is left hand side or right hand side. Okay, left hand side you can divide it as, this is right hand side. So this is the section which I have cut. This is left hand side and this is right hand side. Same one I'm showing here, left hand side and right hand side. So left hand side of the beam, if the forces are moving upward, then it is positive. On the right hand side, the forces moving upward will be negative. Wait a second. For left hand side, upward moving positive. For right hand side, upward moving negative. Okay, then similarly left hand side and right hand side. For left hand side, downward coming negative, and for this downward coming is positive. So see here, when I consider left hand side of beam, okay, so upward moving forces are positive. When I consider left hand side of beam, downward coming forces are negative. When I consider right hand side of beam, upward moving forces are negative, downward coming forces are positive. Okay, this is for shear force. Now for bending moment. So we'll consider same LHS, RHS, LHS, RHS. So bending moment will be in the rotation. Okay, so clockwise is positive, clockwise is negative, anti-clockwise is negative, anti-clockwise is positive. So when I consider left hand side of beam, clockwise is positive. When I consider again left hand side of beam, if there is a anti-clockwise, it's negative. When I consider right hand side, clockwise is negative. When I consider right hand side here, anti-clockwise is positive. So these are the things you should know clearly. Okay, so next class we'll see the derivation. Thank you.